Hi everybody in Mr. Pine's G-Block class. This video will walk you through some of the answers, at least, to the packet of questions I gave you. They were intended to be practice questions for the final exam about Chapter 5. So there are several pages here. You might even want to go ahead and number those pages because you're going to see that this is going to probably turn out to be more than one video, and I'm expecting that this first video will just cover the first two pages, pages 1 and 2, and you're going to notice that page 1 comes back up again as you leaf through the packet unless you renumber them. I copied several different pages from several different documents and put them together to make this packet, so there's more than one page 1. Anyway, this is the first page of the cover, the first question of the cover page. And like I said, it's going to go over Chapter 5, and the only parts we looked at were Chapters 5.1, 2, 3, and 5.5. And these first questions here are from Chapter 5.1. 5.1 starts off with this idea of slope-intercept, and it asks you to write an equation of a line in slope-intercept form. Well, the great thing about slope-intercept form is that if they give you the slope and they give you the y-intercept, then all you got to do is plug those numbers in. Slope-intercept form is this: y equals mx plus b. We talked about that a lot back in the late winter and early spring. So m is slope, b is the y-intercept. Well, I've got a slope. I've got a y-intercept. A half is the slope, so I plug half in for m. -3 is the y-intercept, I plug that in for b. And I simply write down y equals 1/2 x plus -3. 1/2 for slope, -3 for b. Oops, sorry about pulling that along. And this right here is the equation that I want. That's my answer. You can simplify it. You can write it as y equals 1/2 x minus 3. You don't have to say plus minus. But other than that, that's the answer. Let's move on to the next question. In this case, you're asked to write the equation of the line when you can see the line. Let me uncover this a bit and I'll show you that you can see the line there. So again, slope-intercept form, I need those two pieces. Whenever it's slope-intercept, those are the two pieces I need. Well, I can count off the slope. What I do is I figure out where my line crosses the crosshairs of the grid, and it looks like it crosses right there. And there's another place where it looks like it goes through the crosshairs, and that's how I did the figuring. And I know that slope is the same thing as rise over run. And so from this place in the crosshairs, I go up 4 and over 1 to get to another place in the crosshairs. That means rise 4 over 1. 4 over 1. That's my slope, 4 over 1. Now my intercept is where my line gets intercepted by the y-axis. Well, there's the y-axis right there, and it gets intercepted. It looks to me like it gets intercepted at 3, and that's what I've written here. That the y-intercept, let's uncover this. The y-intercept is 3. Okay, well those are the two pieces I said I need. I need the slope, I need the y-intercept. Slope's 4, or 4 over 1 if you want to call it that, and y-intercept is 3. So my equation is y equals 4 over 1x plus 3. Or like I said, you can call it just plain 4x if you want to, plus 3. Next slide. Now we put it into a word problem. So I need to make sure that you understand that, let's look back at the picture, the y-intercept is considered to be where you start in your growth or your shrinking of one of these linear equations. So in this case, you start, or the babysitter starts, at $20. Doesn't matter whether the babysitter babysits for 15 minutes or 15 hours in a night. She's going to charge $20. Plus she's going to charge $2 for every pet that's in the house. It's a strange word problem. That this is the word problem we have to work with, so let's live with it. So $20 is her y-intercept. That's the starting amount. $2 is the rate of change. That's the slope. Slope is the same thing as rate of change. And so that's what I say here. The constant, or the y-intercept, is $20. That's not going to change. Doesn't matter how many hours she babysits. The slope is the thing that does change, and it tells how much it changes. It changes $2. Oops, I wrote $2 per seat instead of $2 per pet. Don't know why I said that. But anyway, let's put those two pieces together. Just like we did back here, we put slope and y-intercept together and made this equation. We'll do the same thing here. We've got a slope and a y-intercept. Slope's 2, y-intercept's 20. Put them together in an equation, and we get y equals 2x plus 20. This describes this story right here. Okay, so let's see, where are we on the first page? We got one more question on the first page, right on schedule. This time we're supposed to do a different form, point-slope form. This is no longer slope-intercept form. It's very easy to get these two forms confused. Point-slope form is best when they give you one of the points of the graph and the slope. Well, that's what's happened here, so it's ideal. Point-slope form is not y equals mx plus b. It's y minus y1 equals the slope, or m, times x minus x1. And the y1 and the x1 are the coordinates of that point that they've given you. So all you do is plug it in. This is x1, that's y1. So y minus y1, as they say here, is y minus, well, there's y1, negative 2. Y minus minus 2. The slope, right there, they say it's negative 5. Put that in. And x minus x1 is x minus, well, there's x1, minus 4. X minus minus 4. So it might make more sense to simplify these minus minuses. You could write it as y plus 2 equals negative x times x plus 4. Same answer. I don't care either way, whether you write it the way I have here or the even simpler way. Both are fine with me. Okay, that's the end of page 1. I think we're going to have enough time for page 2, so let's move on to the top of that. And the first question you were asked was another point slope question, but this time they don't give you the slope. They do give you 2 points, though, instead of 1, so there's a bit of a benefit, but you're going to have to figure out what the slope is. And there's no picture to go from to figure out what the slope is. Well, slope, like I said, you need slope, and slope is rise over run. Just like way back on that picture, I'm going to go back for a second, just back to this picture that we had here, rise over run. Okay, so in this case, it's still rise over run. Rise is the change in y, or y2 minus y1, over run, x2 minus x1, the change in x. So let's do. There's a y, 3. There's a y, 5. The change is 3 minus 5. And there's an x, another x. The change is 1 minus 0. So 3 minus 5 is negative 2. 1 minus 0 is 1. And there's my slope, negative 2 over 1. That's half the battle. Remember, I need a slope and a point. But you know what? I do have a point. I actually have 2 points to choose from. Let's see which one I picked, because I think I only did one. Okay, I picked 5, 0. And I went ahead and plugged it in to my y minus y1 equals slope times x minus x1 formula. This time y minus, well, there's my y1, y minus 5, equals slope, that's what I figured out right here, negative 2 over 1, times x minus, well, there's my x1, 0. And that is a perfectly good formula or equation for the line. You could have written using the other points if you wanted, point xy if you wanted to. That way would have been y minus 3 equals negative 2 times x minus 1. Either of those is a perfectly good answer. Moving on to the next slide. And the next question, another slope-intercept. Oh no, I'm sorry, going back to slope-intercept form. Going back to y equals mx plus b form. And this time they give us a slope and they give us a point. So how do you deal with a point and a slope when you're not asked for point slope, when you're asked for slope-intercept? Well, remember, I've got slope, so that's good news. I can plug that in. And my slope is going to be the negative 1 that they've told me, and I've just gone ahead and put it in. But the next thing I'm going to have to put in, because I don't know what my y-intercept is, but I do know an x and a y. There are the x, y that I know. So I'm going to plug those in. Instead of y and x here, I'm going to plug in 5 for y and 3 for x. And so now I've got 5 equals -1, that same slope, times 3 plus b. Okay, well that means 5 equals -3, multiplying that out, plus b. And if 5 is -3 plus b, move the -3 over, and I'm going to have b is equal to 8. And that's what this says over here. If 5 equals -3 plus b, then b equals 8. Okay, well now I got the two pieces. Remember, for slope-intercept, I need a slope and an intercept. B is my intercept. My slope's -1. Put them both in, and my equation is y equals -1x plus that b plus that intercept plus 8. That's my answer in slope-intercept form. Last slide for page 2, and I think we'll stop the video after we do this one. Very similar to the last question, but here we're talking about two different lines. Write an equation of a line that's parallel to this equation, y equals 5x plus 2, and goes through this point. Well, this is something you're going to have to remember. Remember that parallel lines have the same slope. So on the previous question with slope-intercept, I needed slope and intercept, and they gave me slope and a point. Well, here they've actually given me slope and a point again. My slope is going to be 5. So it's going to be y equals 5x plus b. It's not going to be plus 2. That's the other line, not the one I want. But it at least is going to have the same slope. And again, I'm going to plug in 3 and 2, 2 for y. So I've got 2 equals 5 times 3 plus b. 5 times 3 is 15. 2 equals 15 plus b. I move the 15 over, and I'm going to find out that b is -13. Now I've got the two pieces I want once again. I've got my slope of 5, my y-intercept of -13. I put them together, and I've got y equals 5x minus 13. That's my equation of the line I was looking for. And that's the answer to this one. This is where we're going to stop this video, and we'll pick it up on a second video from here.